Alright, so we're going to finish up section 3. This is the pH concept again, part 2. And here's our objective. So we want to be able to talk about the pH, pOH, kW, be able to calculate hydrogen ion concentrations, hydroxide ion concentrations, pH, pOH, all that stuff. Talk about acidity or basicity of a solution in terms of hydronium, hydroxide, and then be able to predict whether something's acid, base, or neutral based on what you know about hydroxides, hydroniums, and all those various things. Alright, so first of all, most of the acids and bases that you deal with in a lab, or that most labs use, are usually not terribly concentrated. They're usually somewhere between 1 molar and smaller than that. So like things that, if you take vinegar, pop, orange juice, things like that. But these numbers, these are not kind of easy to work with. And so a guy named Soren Sorensen decided to come up with a better way. What he wanted to do is get rid of the exponent. And so came up with pH, which we have, numbers that range usually between 0 and 14. So much easier to work with than those other numbers. And this is how he did that. What he simply said was take your hydrogen ion concentration, so let's say it was that, plug it in, take the log of it, that usually gives you, it always gives you a negative number, and then take the negative of that, and that will be your pH. So let's take an example. Let's say that we wanted to find the pH of a solution whose hydrogen ion concentration is 0.01. So this is what you do. Plug it into that equation. Plug into that equation of pH equals negative log of the hydrogen ion. So we put in 0.01. And if you're using a calculator, you're going to put in 0.01 and then do log. At least that's the way my calculator is. If yours is a little different, if you do the log first and put it in that way. But mine, I always put in the number, then push log, and I get a -2. And it's the negative of that. So it's going to be negative of -2 or +2. So if you have this hydrogen ion concentration, you have a pH of 2. Okay, well, let's work it backwards. Let's say that you have a pH of 4, and we want to figure out what the hydrogen ion concentration is. Well, if we look at this, what we find out is that the hydrogen ion concentration is equal to 10 to the negative pH number. And that's if these are whole numbers. So also, if the hydrogen ion concentrations are always 1s, then the pHs always come out to be whole numbers. If the pHs are whole numbers, then you're going to get these decimals, either 0.1, 0.01, 0.001, and so on. Okay, so we can do this. The other thing, if you understand the math, you can just plug it in and say, oh, okay, it's going to be 10 to the -4th. Or 1 times 10 to the -4th. Or if you don't do that, you can do it on a calculator. In this case, you have to do the inverse function of the log. And so you're going to put in the number that you have, but you have to make it negative or you're not going to get it right. So you got to take the number, so take in the 4, make it negative, and then do inverse on minus inverse or second function log. Okay? And then you're going to get 1 times 10 to the -4 or 0.0001. Alright, so let's take a look at this one. It says, what's the pH of saliva if the hydrogen ion concentration 1.58 times 10 to the -6. Since this is not the number 1, it's not 1 times something, you won't, it's not going to give you a whole number. So this, at this point, is just simplest to do it on a calculator. So take the 1.58 times 10 to the -6, put it into the calculator. So 1.58 times 10 to the -6, and make sure you get, put it in there right with the exponents and stuff. Do the log, and then take the negative of that. And I get 5.8. That's kind of a weird looking 5. 5.8. Okay. So on the pH scale, if anything is less than 7, okay, less than 7 you have an acid. equal to 7, it's neutral, and greater than 7, you have a base. Okay, so 0 to 7, or less than 7. 7 is exactly 7 is neutral. Anything less than that, acid. Anything greater than that, base. Now, we have the pH, which we said was the negative log of the hydrogen ion concentration. But we can also have the pOH. Okay, so we can do that same thing to hydroxide ions. Okay, so we have the pOH. Now, because we're figuring the opposite of the pH, these things are switched around. pOH, if any pOH that's greater than 7 is an acid. If you have the pOH greater than 7, the pH must be less than 7. Anything neutral, 7 is still neutral, and if the pOH is less than 7, it also means the pH is greater than 7. Therefore, it's a base. So it's important that you can identify. If I said, hey, the pOH is 4, you need to be able to tell me, is that an acid, a base? Is it neutral? You need to be able to do that. Or if I said the hydrogen ion concentration is, is 0.001, what is that? You need to be able to tell me whether that's an acid, a base, or what. Once again, this is, if you do it as an exponent, it's 1 times 10 to the negative 3. That exponent, if this is a 1, that exponent, not the negative sign, but the 3, that tells you the pH. So the pH is 3. Therefore, that's going to be an acid. All right, so kind of the key new thing here is right there, is that the totals of the pH and the pOH always equal 14. So if the pH were 3, pOH has to be 11. If the pH were 8, pOH 6. Always have to total 14. All right, so let's do another example. Let's say we want to know what the hydrogen ion concentration is, but we're given the hydroxide ion concentration. Okay, remember the other day we said that if you multiply those two concentrations, multiply those two things together, you get 1 times 10 to the negative 14th. All right, so plug in what you know. You know the OH. Okay, we're trying to figure out H, but we know 8.23 times 10 to the negative 6, and we know it's going to equal 1 times 10 to the negative 14. Now, this is just an algebra problem. It's got some exponents, but it's still just a basic algebra problem. So divide both sides by 10 to the negative 6, that one. 8.23 times 10 to the negative 6. So if I do that, 1 exponent 14 negative divided by 8.23 exponent 6 negative, and I get 1.2 times 10 to the negative 9. That's what I get for an answer. Okay. All right, let's do this one. It says black coffee has a hydronium ion concentration of 1.26 times 10 to the negative 5. What's the pOH? So if I put that in, take the log, negative of that, I get the pH equals 4.9. Now, if the pH is 4.9, we add that to the pOH, they total 14. So 14 minus 4.9 should give me 9.1 for the pOH. Okay, so keep in mind, there's kind of two main things. Keep in mind that the pH plus pOH equals 14. That's if we're dealing with pHs. If we're dealing with hydrogen concentrations, H plus times OH minus equals 1 times 10 to the negative 14. Run out of space. 1 times 10 to the negative 14. Okay? All right. All right, so there you have it. Now, I know that some of that stuff's a little confusing. My best suggestion for you is if it didn't make sense, go back, listen to it again, read the textbook again, take a look at it. It does make sense if you kind of slow it down, take a look at it. You know, your job is to go over it until you get it.